Good morning.
I'll start recording this. All right, so last time we saw how to find the vertex, right? How to find the vertex of, of a quadratic equation. So now we're gonna see what to do to graph a quadratic equation. So we're gonna do that. So let me share my screen. Okay, so basically we said we have if you have a parabola, we have 4 distinctive points, right? On any parabola, probably. So the one of them is a vertex. Okay. And last class we saw how to what are the 2 steps to take to get the vertex. One of them is a y-intercept. Right? Now look, if my equation is y equal ax squared plus bx plus c, if that is my equation, right? So for any y-intercept, how much is the x? That point right here is the y-intercept. How much, by definition, how much should be the x equal to? Can somebody answer, please?
Is it 0?
The x has to be 0. So, for the blue point, the x is 0, right? That is always true for the y-intercept. The x always has to be 0. So now, if you set x equals 0, look at the equation. Y equal ax squared plus bx plus c. When you substitute x with 0, how much is going to be y? You can do that in your head. How much is going to be y?
0? I don't know.
I mean, go ahead, substitute. Everywhere you see x, put 0 in there. Y is going to be how much? For the y-intercept, can somebody tell me how much y is going to be? So we set x equals 0, right? When you set x equals 0, you get y equal a times 0 square plus b times 0 plus c. C 0, 0. How much is y then? Y is c, right? Everybody see that? So the y-intercept is a point 0, c, always. Always, right? The y-intercept for a parabola, the y-intercept is the easiest point to find. Is the point 0, comma, c. Now for the x-intercept now, is this one and this one. This is x-intercept and the x-intercept, right? For these 2 green points, how much is the y? How much is the y for these 2 green points? I mean, am I talking to myself?
No, I'm thinking. 0.
It's like quiet this morning. The y is 0, right?
Yes.
For these 2, for the 2 green points, the y is 0. For the x-intercept, the y is 0. You see? So if the y is 0, then you have 0 equal ax squared plus bx plus c, and we have to solve it. With any method that we want, we have to solve this to get the y-intercept. I mean, to get the x-intercept. Okay, so the vertex, we saw how to get the vertex last time, right? The y-intercept, no need of no calculation is gonna be the C. The x-intercept, eventually, you're gonna have some calculations to do. If you have these 4 points, then you are ready to do your graph, right? That is what you're gonna learn now. So let's do together a first example of that. Okay, so let's try to graph y equal x squared minus 2x minus 8. So graph find. So we're going to define vertex y-intercept, x-intercept, and graph. So we have y equals x squared minus 2x minus 8. Okay? That is my y. As we said, what point is easiest to find? Of those 4 points, which one is easiest to find?
The y-intercept.
Exactly, the y-intercept. That is the easiest, so we're going to start with the y-intercept. It is the easiest point to find. So y-intercept, we said no need of no calculation. Can you tell me what is y-intercept, somebody?
-8.
-8, thank you. Is -8. Some people write only the value, or if you're doing, for instance, you are doing my open math, maybe it's going to ask you to write the point. Is the point 0 for x, -8 for y, right? That is y-intercept. So if I go graphing my stuff, so every time I got a point, I'm going to graph the point right here. I'm going to graph it. So insert some axis right here, x-axis, y-axis, right? So the y-intercept is -8. So I'm going to put some units, right? 1, 2, 3, 4, 5, 6, 7, 8. That is the y-intercept, okay? All right, after the y-intercept now, what you want? You want to go to the vertex? Let's go to the vertex, right? For the vertex, remember, there are 2 steps, right? The vertex is the point, It has a h and a k. Somebody remembers what you have to do? What quantity will give us the h? Do you remember that last time?
Is it
From last.
we have to know a and b, and then
Mm-hmm.
we do -b over 2a.
Thank you very much. That is absolutely correct, right? Is -b over 2a. To find the h is -b over 2a, right? -b, oh, you see, -b over 2a, that is my first stuff. The b is -2, it's going to be -2 over 2 times 1, that is 1. You see, that is a 1 right here. And then somebody else, can you tell me what is the next step to do to get the k, the second number, the second coordinate?
So now you take h, which is 1, and you plug it in where x is.
Exactly, thank you. So now you take 1, you plug in 1, you get 1 squared minus 2 times 1 minus 8, which is 1 minus 2 minus 8, which is -9, and that's going to be the k. So my vertex is a point 1, -9. So it is 1. I have 1 here, and -9, which is here. 1, -9. That is my vertex. You see, probably, okay, right here. This parabola, what do you think? This parabola opens upward or opens downward? What do you think?
Upward.
Upward. What is the deciding factor of that? What number decide if it is upward or downward?
A.
The A. How much is A?
It's 1.
Is 1, positive, right? So my parabola opens upward, right? It opens upward, so probably my parabola will be like this, you know, probably it's gonna be like this, okay? But I need to know what are the x-intercept, right? I need to know that. You see what you're gonna do? The x-intercept now, we're gonna set x squared minus 2x minus 8 equals 0, and we're gonna solve it, right? Now I have to go through my toolbox, right? Which means, do I have to factor? Do I have to use a quadratic formula, etc., etc.? If the example looks nice, I'm going to give it a trial. I'm going to try to factor real quick. If the example looks nice. If the example does not look nice, I just go ahead and use a quadratic formula, right? Somebody, do you see any factoring here that we can do?
X plus 4, x minus, or excuse me, x minus 4, x minus 2, x plus 2, excuse me.
X minus 4, x plus 2, thank you. You see, if you don't see this, you can always use a quadratic formula. So we got x equal 4, x equal negative 2. These are the two x-intercept. Again, you can write them as numbers, I mean as points. You can write 4, 0, and negative 2, 0, right? Remember, also you can also use a quadratic formula, right? If the example does not factor easily, you can use a quadratic formula, right? So I have 4, 0 and negative 2, 0. I have 4, 0, which is 1, 2, 3, 4, and 1, 2. So my graph, these are the x-intercept. My graph will be like this, right? Everybody see that? This is a parabola. So now if you look at the middle of the parabola, if you look at this line right here, that is the axis of the parabola, right? That line is the middle line. You see, if my graph was accurate, the left part and the right part will be completely symmetric, okay? That is how we graph a parabola. Everybody see that? I'm going to give you another one. You grab a piece of paper and you try to do this one. Y equals, find the vertex, x-intercept, y-intercept of y equals negative 2x squared plus 12x minus 10. Find the y-intercept, the vertex, the x-intercept, and then graph. I give you like some good 6, 7, 8 minutes for everybody to try that by themselves, please.
Mm.
I have a question about,
Yes.
I should know my PEMDAS by now, but when we plug in the H into the Y equals formula,
Mhm.
do we multiply the first number by the plug-in number, or do we square it first?
You square first. Yeah, that's a good question. You square first.
Okay, thank you. I didn't catch the part where you how figured out the x-intercept.
Yeah, for the x-intercept, you have to set the equation to 0, and then you try to solve it now. If you see that you can factor easily, you go ahead, you factor easily. If not, you have to remember, you always have the quadratic formula.
Okay.
Right? Which is like the default method to solve equations.
But if we set x to 0, wouldn't it just come out to -10?
Yeah, that's for the y-intercept.
What
That's
if,
for the y-intercept. For the x-intercept is the other way around. For the x-intercept, is the y that is set to 0, right?
Oh, right. Okay.
Yeah. All right, so everybody, so let's go with the easiest point to find. The easiest one is what point? The y-intercept, right?
Y. Mm-hmm.
How much is the y-intercept here?
0 and -10.
0, -10, right? 0, -10. Thank you. So that is the y-intercept. You see, that is y right here. Okay, so by the way, this parabola will open upward or will open downward?
Downward.
Downward, right? Again, because -2 is negative, right? So for the vertex, we do negative b over 2a, which is -12 over 2 times -2, which is 6. I mean, which is 3, right?
Yes.
Okay, now what you do, we plug in 3 back to the equation, -2 times 3 squared plus 12 times 3 minus 10. Exactly, this is what you were talking about, right? We have to square 3, which is 9, and then we multiply. It's going to be -18 plus 36 minus 10, which is 18 minus 10, which is 8, right? So what is the vertex? The vertex is a point 3, 8. Do you agree with that? Everybody, you have the same answer?
Yes.
3, 8. So that is the vertex. So 3, 8. I have 3, 1, 2, 3, and then 8. 1, 2, 3, 4, 5, 6, 7, 8. So that is a vertex. Okay. So probably my parabola will do something like that, right? So now I just need to find the x-intercept. You see, for the x-intercept, right? I look at here. Is my example nice for factoring? You know, if I have slight doubt about that, I just go and do the quadratic formula, right? The factoring method is an opportunity method. We factor, can we see the opportunity? Okay. When we see the opportunity, we factor. If we don't see it, or if it does look like some type of challenge, we just go ahead and do the quadratic formula, right? So basically what my point is, don't spend a couple of minutes trying to factor. Don't never do that. Okay? Unless we ask you to factor. If we don't ask you, you do it like within the next 20 seconds. If you don't see it, just do the quadratic formula. So A is, so somebody tells me the quadratic formula is negative what? Negative?
Negative b plus or minus
Who is B here?
12.
12 is negative 12 plus or minus square root of B square, which is
12 squared
12 square minus
4 times a, which is negative 2, times which is negative 10,
yep,
all over this
all over
2 times a, which is negative 2.
exactly. And we just go ahead and simplify, which is negative 12 plus or minus. Remember, so the inside 12 squared is 144, right? That is 144. And here, and then these three minuses, minus, 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 they combine, they become a minus, right? And this is 4 times 2, which is 8, 8 times 10, which is 80. Is 144 minus 80, which is 64. And then square of 64, all over negative 4, which is negative 12 plus or minus 8 divided by negative 4. It's going to be negative 12 plus 8 divided by negative 4, which is negative 4 divided by negative, which is 1. Or negative 12 minus 8 divided by negative 4, which is negative 20 divided by negative, which is 5, right? Which is 1, 5. So my two x-intercept are 1, 0 and 5, 0, right?
Where did the 4 come from in the beginning?
In the quadratic formula?
Yeah.
Because the denominator, I mean, you mean this 4 right here?
Yes.
It is part of the formula.
Oh, whoops.
Yeah, is you know, inside the square you have b squared minus 4ac. All right, b squared minus 4ac. This is where the 4 comes from. Okay, so we have our two x-intercept are 1, 0 and 5, 0, right? 1, 0 and 5, 0. So we have 1, 0. So by the way, I can go ahead and remove the graph so it doesn't bother us too much, right? Okay, so we have 1, 0, which is right here. And 4 and 5, 0. And this is my parabola, like this. And this line right here, which says this line, this vertical line, is what you call the axis of symmetry. That is like the middle line. Like this is the middle of the parabola. Everybody see that? Everybody see what we need to do to graph a parabola? Everybody see that? Now you can tell me what part of these 3 points, y-intercept, vertex, x-intercept, what part do you have any problem? Can you tell us right now so we're going to explain again? Or are you confident? Everybody is confident they can find the x-intercept, I mean the y-intercept. Are you confident you can find the vertex? And are you confident you can find the x-intercept, right? If you are confident you can find those 4 points, then you can graph any parabola, any, right? The y-intercept.
I said I feel confident. I just had to memorize the. It's just trying to memorize the equations. That's all.
Yeah, we have to. You have to memorize the quadratic formula. I mean, memorizing again. I explain again. Memorizing is not a dirty word in math. You know, Probably this quadratic formula right here, I memorized it like since I even don't remember. I did memorize it when I was a kid. So I did memorize this stuff. And why I didn't forget about it? Because I'm using it every day, right? So if you have math classes to come, if you have, pre-calc, math 163 or something like that, you need to know the formula, okay? And the best way to know a formula is to know it through practice. That is the best way. To know the formula, it's to know the formula through your practice. You practice one problem, two problems, three problems, and then it's just gonna come, All right, so let's do one last one here. I'm gonna give you, some good minutes. I want everybody to find the 4 points, right? Another example, I want everybody to find the 4 points. Y equals negative x squared plus 4x plus 5. Some very nice numbers. By the way, look, the vertex, remember the vertex? Let's come back to the vertex 1 second. This vertex is 3, 8, right? 3, 8. It tells me what? It tells me something about the maximum, right? It tells me what, if somebody asks you, what is the maximum? What's your answer? What is the maximum value of y?
When
Your answer should be, what is the maximum from the vertex? Your answer should be the 8, right? What is the maximum value? My answer is 8. When do we reach the maximum value?
when x is 3.
When I see when do we reach the maximum? When I see that, I say when x is 3, right? Okay. The vertex allows you to answer these 2 types of questions. What is the maximum? It is the y coordinate of the vertex. When do we reach the maximum? It is the x coordinate of the vertex, etc., etc. So you're going to see why I talk about that. So I'll give you some good 5 minutes, everybody. Try to find the y-intercept, the vertex, and the x-intercept. All right, go ahead.
So I have a question again about plugging in
Yes.
H. When I'm plugging that in, and the number is a positive number, I would square it and then add the negative.
Yeah, you square it first and then multiply by any negative number in, yes. If it is negative sign in front, you put the negative. The negative sign is not involved into the squaring.
So then if it was positive and I squared it, it would end up being negative?
Yeah, whatever number you see, that expression, the negative sign, negative x squared, that negative in front of the x squared has nothing to do with the square itself. Whatever number you have to square that number first, and then you put a negative sign in front of it.
Okay. So if we see that the x-intercepts, if they, what do they call it? Instead of doing the quadratic formula, what is it called?
Factoring.
Factoring. If it factors nicely, then it's like really easy to find that.
Yes, that is absolutely right. If it does factor nicely, then it's going to be quicker and it's going to be easier.
And those two numbers that we would use to factor, we would just put those in the x and then 0.
Yes, that is right. All right. Okay, so now everybody tell me, what is the y-intercept?
Is it 5?
It is 5, right? We say 5, or we write 0,5, right? The vertex. Do you have the answer for the vertex? Are you going to see?
It's 2,9.
2,9. Let's check together. So we say negative b over 2a, which is negative 4 over 2 times negative 1, which is 2, right? Okay, you are right.
Yep.
And then we say negative 2 squared plus 4 times 2 plus 5. That is negative 4 plus 8 plus 5, which is 9, right?
Yes.
So the vertex is 2,9. Now for the x-intercept now, if you factor, make sure you factor it right. I'm always suspicious if I have a number in front of the x square like that. If there was no number in front of x square, I would be more confident.
Wait, can you, I don't want to take away from class time, but can we go over that again? The vertex, whatever? Yeah,
the vertex, we have to do like two steps. The vertex, the first, it is a point. Any point has an x coordinate, has a y coordinate. How to get the x coordinate? This is given, this is a given, this is a formula. It's negative b over 2a, right? And you have to remember that formula, okay? You do negative b over 2a. The a is negative 1, and the b is 4. It's going to be negative 4 over 2 times is 2. Now,
So
what is the second
A
step?
is the where the x squared is?
Yeah, the A is a number in front of the x squared is -1 right here.
Okay.
Okay. And then the next step, the second step is to take whatever number you got here and to plug it back into the equation for x. That's going to give you the k. That's going to give you the second number. And this is what we did here. Okay. That's how we get the vertex. This is how we get the vertex. Now for the x-intercept now, I was saying, if I see some very easy factoring, I go ahead, I factor. But me personally, I'm always suspicious when I have a number in front of x squared other than 1. Let's do the quadratic formula, which is safer in this case. It's negative b, which is -4 plus or minus square root of b squared, which is 4 squared minus 4 times -1 times 5 all over 2 times -1, right? Which is -4 plus or minus square root of, that is 16 plus 20, which is 36, all over -2, which is -4 plus or minus 6 divided by -2. This gives you -4 plus 6 divided by -2, which is -1, or -4 minus 6 divided by -2, which is 5, right? So my two x-intercept are -1, 0 and 5, 0. Okay?
Probably
Now-
better you did that quadratic formula because I put 4, 0, and 1, 0 as my I didn't pay attention to the negative sign.
Yeah, you see, that exactly. That personally, I avoid factoring every time I have a number other than 1 in front of the x squared. You see, because then you have to do the AC method. You see, if you have a number in front of the x squared which is not 1, then to factor correctly, you have to do the AC method, right? But now that I have a quadratic formula, I don't rush to it. I don't rush towards the quadratic formula, but you know, it is a very nice tool. And you have to memorize it, everybody. You have to memorize the quadratic formula. Okay, so I'm not going to graph this one, but I'm going to say this is how the graph look like, right? And that point is 2, -2, 9, right? It tells you what? It tells you the maximum value is 9, reached when x is equal to 2, right? Okay, so now go ahead and we try some applications. Applications, like a couple of word problems. All right, let me see if I can grab an example from the textbook or from my open math. Right, my open math is here, quadratics, applications, right here. Good. Okay, so let me get the first one. It has some nasty numbers, but application problems, they always have some nasty numbers. Okay, everybody see that? NASA launches a rocket at t = 0, right? Its height in meters above the sea level in terms of the time is given by h. Do you remember something like that? Do you remember something like that when we did test number 1? Do you remember that?
The work problem?
Yeah, I mean, not the work proposed. This is like in test number 2. But something like that in test number 1, we said something goes up and then comes down, right? You see that here is the rocket. The rocket goes up like this and then comes down to the ground. Do you remember we asked the question, when the rocket or the object will reach the ground, will hit the ground? Remember that? And then we said at the ground, how much was the height at the ground?
0.
We said the height was 0, right? What variable here in the equation, what variable represents the height?
H.
The h. You know, we set equal 0 and then we try to solve, right? Okay. So we're going to do about the same thing here, but except here now, we can ask some more questions. I'm not asking these questions right here. These are like, you know, this is not the type of way we're going to ask. I'm going to ask this question right here. First, when the rocket will reach the maximum height? That is the first question I'm going to ask. When the rocket will it reach the maximum height? Means here when. After how long the rocket will be here? That is the maximum height, right? Everybody see that? Okay. When I say that, the equation is given to me like that. By the way, this equation comes from physics, okay? But we're not investigating where the equation comes from. When the rocket will reach the maximum height, there is a key word here that makes me think that the answer will be given by the vertex. What is the key word?
Max height.
Max, exactly. Thank you very much. Every time in the context of a parabola, every time I see the word maximum or I see the word minimum, the answer lies in the vertex. Okay? The answer is in the vertex, right? Now, the vertex is the whole point, right? The vertex is a point that has an x coordinate and has a y coordinate, right? Okay? The vertex is a point that has an x coordinate and has a y coordinate. So, sometimes the answer will be the x coordinate of the vertex. Sometimes the answer will be the y coordinate of the vertex. If we come back here, again, come back to this one. I said, if the vertex is 2, 9, right? When I say, when do we have the maximum? What's going to be your answer, the 2 or the 9? When do we reach the maximum?
The 2.
The 2. Everybody agree with that? Here, when you say when do we reach the maximum? The answer will be 2, right? After 2 something, 2 seconds, 2 days, or something like that, right? Now, when you say, what is the maximum? What's going to be your answer? Your answer is?
9.
9, right? The answer will be the 9. You see, same thing here. So here, when we say, when the rocket will it reach the maximum height? The answer will be, because of this when right here, the answer will be the h of the vertex. Is the h of the vertex.
So wait, I'm also still confused. Why is 1? I don't get it. When and what? How do you know? Why is 1?
Yeah, I mean, this is about the vertex. You know, part of it because, you know, like you said, you missed the last class. Because, you know, in the last class, we elaborated about the vertex, what the vertex is for the parabola, right? We talked about it the most. So, and the recording is, you know, is in bright space. But just to tell you, in the context of the parabola, the point that is called the vertex tells you what is the maximum, what is the minimum, right? It is either the highest point of the parabola or either the lowest point of the parabola. Okay, that's going to be the vertex. You see that point right there, the red point right there. It is the vertex, right? It is the highest point in some context. It is either the highest point or either the lowest point, right? This always is the vertex.
Okay.
And it tells you what is a maximum or what is the minimum, you know, depending on how the parabola is opened, right?
Mhm.
So in this case right here, the rocket is going up and then coming down. It tells me what's going to be the maximum. Now, we have two questions. What is the maximum? Or when do we reach the maximum, right? Okay? You see, if I tell you what is the maximum, and if I tell you when do we reach the maximum, these two questions are different, right? Are they the same questions? Are they the same questions? So what is the maximum temperature in Baltimore? What is the maximum temperature in Baltimore? You're gonna say 110, right? When do we reach the maximum? When do we reach that maximum? You're gonna say the
Summer.
summer. You see, these two questions are different, right? What is the maximum? The answer you give, and when we say when do we reach it, the answer you give, these are two different answers. The vertex tells you that if this vertex, we haven't done the calculations yet, if this vertex was 3 and 478, if this vertex is 478, right? It is not, but I just assume it is. When I say, when do we reach the maximum? What's going to be your answer? The 3 or the 478?
3.
The 3, right? When do we reach it? We reach it when x or whatever variable, when t is equal to 3 seconds, right? What is the maximum height reached by the rocket? What's going to be your answer? 478, right? This is exactly what I'm talking about. So now the answer is, every time we say, when do we reach the maximum? When do we reach the maximum? The answer will be the h of the vertex, which means the x coordinate of the vertex. And how we get the x coordinate of the vertex? How we get it?
The quadratic formula.
Not that. The negative. How we get the first number of the vertex? How?
Oh,
Negative b over
2a.
Exactly. You see, the answer is very, very, very short. Is negative b over 2a. That's it. Which is, b is 226. It's going to be negative 226 over 2a. A is negative 4.9. Right? Which is negative 226 divided by negative 9.8. And then we do the math. How much is that?
Nasty number.
Yeah, it's not a nice number. 9.8, which is 23.06.
Did you just do that in your head?
I use my calculator, my cell phone.
Okay.
That's just too much for the head. Right? It's 226 divided by 9.8 is about 23.06 seconds. When the NASA launches the rocket will reach the maximum height after about 23 seconds. Okay? That is the first question. Now the second question, which is also about the vertex, is this one. What is the maximum height reached by the, what is maximum height reached by the rocket? And because we are asking actually what is the maximum value, because we are asking that, because of this, the answer will be the k of the vertex. the y coordinate of the vertex. And how we get that? How we get that second coordinate? How we get it? What we do?
You plug in the x.
Exactly. We plug in that number, which is not nice. We plug in that number into the equation, right? Okay. So this is how we get. You see, we do exactly what we did here. The only thing here we do is step by step. You know, this first thing is the answer of the first question. This one is the answer to the second question. That's it, right? So what you do? So we plug in 23.06 into the equation. The equation is so it's going to be negative 4.9 times 23.06 squared plus 226 times 23.06 and then plus 283. All right. And then we do the math. You see, it's going to be. Can you do the math at the same time? Can you do the, if you have a calculator at the same time as me, so we can compare our answers? It's 23.06 squared times 4.9 negative, right, plus parentheses 226 times 23.06, close it, plus 283 is 2888.9, right? In what? Is this mile or feet or in meters, right? Meters.
I didn't get that. I got 8,099.
You didn't get that? Yeah, I mean, I can be wrong. Yeah, you have to square the first one. If you do that in your calculator, you can start with the square. You can do 23.06 and then you square that. When you're done, you multiply by negative 4.9, right? So I think this answer is a reasonable answer. Okay. So this is, if you have these word problems that talk about what is the maximum, what is the minimum, etc., they all about the vertex. All of them. Every time you see the keyword maximum, every time you see the keyword minimum, it is about the vertex, right? Okay, so right here, this one right here. Insert.
Are you writing something? Hello?
Professor, you're frozen.
Noel, did you ask Dr. All if he taught statistics?
Yeah.
He is a really good math teacher, right?
Yeah, I like him.
Me too.
Do you have to take statistics?
Well, I already did, and I was going to suggest the teacher that I had. And her,
Yeah, I mean, I'm sorry, you know, that's his teams, you know, teams now, they just acting crazy. I was
Just
talking to my,
put it in the chat.
I was talking to myself, you know, for I don't know how long I was talking to myself. Right. So everybody, do you see the this one right here? Yeah, I knew something was wrong when I asked the question and nobody was answering. So I said, okay, something's wrong. All right. You see the h here is given, the h is the height of the object. The h is the height of the object after t seconds, right? It is the height of the object after t seconds. That is the h. That's what h represents. If I just ask you like that, what was the height of the object after 5 seconds of the launch? What you do? Somebody. That is also, I mean, that is not the question you see here. But if I just ask you right here, everybody, what is the height?
Did you just multiply them together?
After 5 seconds. The 5 seconds here will be the value of what variable? The t of the h. What do you think?
The t.
The t, because the t is t seconds, right? Then the height is what variable? Is h, right? And the 5 seconds is the t. If I ask you this question, what is the height after 5 seconds? It's very simple. Everywhere you see t, what you do?
You multiply them together.
You substitute what? Before you do the multiplication, everywhere you see t, you substitute 5, right? Okay, so the answer will be negative 16 times 5 squared plus 32 times 5 plus 560. Okay? You see, people don't like word problems, you see, but the math behind word problems, most of the time is some simple math, okay? Don't say, oh, okay, because I have this word problem, it's gonna be, no, it's not. Most of the time it's not, okay? So what is the height after 5 seconds? I see 5 seconds is a value for the time. I just go ahead and substitute 5 everywhere I see t. Now look at the question now. What is the height that the object can reach, right? What is the highest? The word highest is synonymous of what? Highest is synonymous of?
The vertex, the y of the vertex?
Yes, the answer will be on the vertex. The word highest is synonymous of maximum, right? You see, what is the maximum point that the object reaches? What is the maximum point the object reaches? I know the answer will be in the vertex, right? I know that the answer will be in the vertex. Now, the question is this is going to be the vertex. It's going to be this and this, right? That's going to be the vertex. What do you think? Because here we have what? What is the value? What is the maximum height, right? My answer will be the red square or the blue square. What's going to be my answer?
I'm guessing by your color-coded
What?
that it's going to
No.
be.
Let me remove the colors, you know. So because I have here what there? I have what, right? So now it's green now.
Oh.
What's going to be my answer? The red square or the blue square? What is the maximum height? Remember the vertex. The vertex gives you two numbers, right? When I say what is the maximum height? It's going to be this one. When I say when do we reach the maximum height, it's going to be this one. Okay. That is the meaning of the vertex. The vertex tells you what is the maximum and when do we reach it, right? What is the maximum and when do we reach that maximum? Okay. If we say what is the maximum, the answer is going to be the y coordinate of the vertex. When do we reach the maximum? The answer is going to be the x coordinate of the vertex. All right. So now, how we get the y coordinate of the vertex? How? First, we do negative b over 2a, right? That is negative 32 over 2 times negative 16, which is 1. Now, what you do to 1? We plug in the 1 back, right? We do negative 16 times 1 squared plus 32 times 1 plus 560, which is negative 16 plus 32 plus 560, which is 16 plus 560, which is 576. So now, my vertex is 1 and 576. Okay? This one is in feet, and this one is in seconds. Okay? The x coordinate is the time, the y coordinate is the height. Now, if I ask you now, what is the maximum height? What's going to be your answer? What's going to be your answer? What is the maximum height? What's going to be your answer?
576.
576. When do we reach the maximum height? When? After what? After how long?
1 second.
After 1 second, right? Okay, so every time you see those questions where you have a maximum or a minimum, the answer will be in the vertex, right? And everybody, you should know how to get the vertex. Everybody, you know, those 2 steps we did here, negative b over 2a, and then plug in the number back, you should know how to do that. Okay, for the next test, for the next quiz, etc., etc. So these are only few applications, you know, of the quadratic equations. Now, after the quadratic equations, what have we learned in chapter 4? We have learned in chapter 4 the square root property, right?
That's with the boxes, right?
The square root property is, for instance, when you do this, when you have to solve x minus 5 squared plus 8 is equal to 19, something like that. Okay.
Oh, okay.
No, we move the 8 and then we take square root and we do plus or minus. We have learned completing the square method.
That's the one.
Yes, that's where you have to do the boxes, complete the square method. We have learned the quadratic formula. We have learned how to get the y-intercept, vertex, x-intercept, and graph, right? This is what we have learned in the chapter 4. And this is what you're gonna have in our next quiz, the last one, right? Okay, the last quiz we're gonna do next week. Do you know what time is? Do you refer to the syllabus to know the schedule?
Yes.
Is right here is November 16, which is next Tuesday, right? Next Tuesday, IELTS quiz, everybody should be happy, okay? We're gonna open up the quiz right after class, and you will have like until the next day to turn it back. Just like quiz number 1, like quiz number 2. It's gonna be on chapter 4, okay? It's gonna be probably each topic will have a question in it. Each topic will have a question, okay? That's gonna be next quiz. And when I open it up, when something is open for 1 day and a half at least, everybody should do that, okay? We cannot like miss a whole day and a half and say, okay, this was happening, this was happening. Everybody should do the quiz. That's going to be our last quiz, right? And try to do, good on that, because even though the test, they have more weight and the final exam has more weight, even though that the quiz will help. They do help, right? They do help the grade. So try to do that seriously. It's going to be open next week, all right? All right, everybody. When we come back next week, we're going to start the last chapter, which is chapter 5 of this class. Okay.
Okay.
All right, everybody.
Thank you. Have a great day.
Thank you very much.
Thank you.
Thank
So
you.